In September of 2002, our Geopolymer Institute crew cast massive imitation pyramid blocks. Or perhaps we should say genuine pyramid blocks. We used the same kind of earthen ingredients available to the ancient Egyptians 4,500 years ago. These massive blocks have the same chemical makeup and appearance as blocks of the Great Pyramid. The limestone we used consists of fossil shells called nummulites, like those in the Giza bedrock. Like in Giza, our French limestone is so loosely bound it doesn't require crushing. But unlike in Giza, it contains no kaolin clay. We heap the cement additives, lime, natron and kaolin clay, near the limestone.
The two components will react in the water and build in situ a geological glue, which will then yield the hard geopolymeric rock agglomerated limestone.
We start making the cement by mixing sodium carbonate, found in Egyptian natron, and lime in 500 liters of water. We then add the kaolin, inherent to Giza limestone, and stir the mix with a wooden tool. We dump 1 ton of limestone rubble into the basin and mix it with the cement. Several days later, water has evaporated from the basin, so we remove the disaggregated limestone for making the block. Inspecting the mixture, 95% limestone aggregates and only 5% rock-making binder. Between 12 and 17% of water give it the consistency of wet sand. One squeezes the mixture with his hand and it keeps its shape. This batch will quickly gain strength. We do all of the work manually, forming a human chain carrying buckets from the mixing area to the mold. We pour the limestone concrete mixture in a mold and pack it down with a tool called a rammer. Compacting the material requires little effort. The packing operation encourages cohesion and the denser mixture takes on high strength from the initial curing phase. When the climate is warm and beautiful, our crew rapidly produces a re-agglomerated limestone that proved strong, dense and true to the plant's size and shape. The mold consists of small wooden boards, which can be reused many times for making other blocks. In this ideal weather, the whole process runs smoothly and is very simple. We remove the mold 4 hours later. The synthetic limestone looks like a natural stone. We observe no trace of wood grain. 4 blocks have already been made. Joseph Davidovits presents them. The 2 large blocks weighing up to 4.5 tons, containing most water, have given smoother surfaces. The 2 small blocks weighing up to 1.3 tons, the least wet, take on rougher surfaces.
When you look at the stones of the pyramid, this is what you see. You see either smooth blocks or very crude blocks. And we have replicated all these surfaces just by varying the amount of water, which depends on the climate, which depends on the weather.
Joints between blocks are also perfect. It will take 3 months for the stones to fully cure because of the climate of northern France. In 4,000 years, will future archaeologists insist that our imitation pyramid stones are natural limestone?